On the 30th of April, the very last day of this month, we're almost in May. Justin Timberlake would be quite proud.
Wow.
Because tomorrow, it's going to be May. Okay. Anyway, if you don't get that, go back and listen to Bye 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 by NSYNC. It's a banger. Okay. Honor geometry, you guys will be able to define and identify parts of a circle, as well as find circumference and area. All right. So let's go over parts of the circle and define them, okay? So a little definition here. So circle.
It's a circle.
The set of points equidistant from a given point. I'm going to put in parentheses the center, because the center is the given point that we're talking about.
I think I had a question that was like on a map quiz.
So the set of points equidistant from a given point, which is the center. Now there's a symbol for this as well. We oftentimes have just little symbols for these, right? We talked about that. The symbol for a circle is going to be a circle with a dot in the middle.
Wow.
Why isn't it just a circle? Why does that have to be
Because then it could be misconstrued as an O
or
a 0, which you'll have often in math.
or half an 8?
Yeah, that is
The 8 without the belt. Okay.
No.
So here, an example / visual. You have this circle with center P. So we would call this, we would name it circle P. You could either write that out, or you could do the symbol circle P.
Not big G.
So you name it by the center. So polygons, we talked about how we named it by the vertices. Well, a circle doesn't have vertices, it doesn't have points.
Does it have like infinite sides?
It technically has 0 sides. Unless you want to go, oh, it has an inside and outside, it has 2. But it doesn't have sides.
No, it does have an inside
What
and
if it's
outside.
solid though?
Yes.
Can you turn into circle inside out?
No.
It's flat.
You try to have one
side. It's flat.
Because. Okay, but can you turn it
No, there's no
inside out?
sides.
You'll
Flip it over.
It's all curved. So what happens here, guys, first off, is that all these points are the same distance from the center. And so it's this collection of every single point that's the same distance. So it's just really made up of an infinite number of points that are all so far from the circle. Now, that length is actually what we refer to as the radius. So a radius, we're going to define it as a segment, a line segment. Width, I'm going to abbreviate W/, it means width. Maybe you've seen it before, maybe you haven't. With endpoints at the center and on the circle. So one endpoint's at the center, and one endpoint is somewhere on the circle. I want to note that the plural of radius is radii.
Of radio.
Radiosity.
Yes, it is.
Is it at or
That's Roddy.
at a segment with endpoints?
A segment with endpoints at the center and on the circle.
Like, where do you get the radii from?
What are the radius?
It's not radiuses. It's like a
Radiosity.
Is that an Indian word? Instead of cactuses?
What was that?
Is that an Indian
It's actually
word?
cactuses.
I don't know.
Roddy.
Is there any particular reason you're asking that?
Well, I think I heard about an Indian person that was their name.
Oh, really?
I don't know.
Oh, Roddy Rich.
So here, if you have another circle P, well, as I rated R, a P, the radius would be connecting the center to some other point on the circle.
I already drew it.
So, I mean, you can make it an R. That's fine. So here we have the radius AP or PA. It's a segment. Now you could have infinitely many radii from here. Okay, so don't you have to draw all these. But let's say we have another radius. That could be a radius. That could be a radius. That could be a radius. That's a radius. That's a radius. So all of those are radii. because they all go from the center to being somewhere on the circle. So the radius is the distance that each of the points that make up the circle are from the center. All right.
Equation for the circle, like radius times 5.
Close.
Radius squared times 5.
Nope. Farther. But that's another one. All right. Chord. Okay, we're not talking about like a chord that like you plug in or anything like that. It's actually spelled more like the musical chord, even though it's different than that too. So chord is another segment. This one has the endpoints, so in a segment with endpoints on the circle. So both endpoints are on the circle for this one. That's the next one. So as long as the endpoints are on the circle, it's a chord. So we could do this a ton of different ways. It can go through any 2 points on the circle. As long as the endpoints are on the circle somewhere, it's a chord.
But isn't a diameter technically a chord?
Yep.
But it's a specific.
No, many gosh.
Yes.
It's a direct
Be very
line, right?
specific, yeah.
It's like the line from latitude and longitude.
Okay. Anyone still need this before we move on to diameter?
You can do a curvy chord.
A what chord?
A curvy chord.
But not straight line.
Like a half circle.
Oh, a curvy chord? No.
Like not the whole diameter.
No, because it has to be a line segment, so it can't be curved.
Why do we say chord and not chord?
I couldn't tell you. Great question. Why do we say chorus instead of chorus?
Okay, we're gonna start saying chord
It's
now.
chord and
Chord.
Roddy instead of Randy.
No, that says chord. That says chord down.
Chord and Roddy verse.
Seth is asking the real questions here. All right.
Yeah.
Diameter. Diameter is a chord, like we were just talking about,
You said a chord could be circle. Chord.
that passes. Yep, through the center. Little note here about the diameter is the diameter is equal to 2 times the radius.
Oh, yeah, so it's 2 pi. So 2r
Wait, define what?
So a chord that passes through the center is called a diameter. So it's a more specific type of chord like we were just kind of saying. And mathematically, the measure of it is equal to 2 times the radius, meaning the radius is how much of the diameter? Half.
Wouldn't that be 2 Roddy?
Not diameter.
2 radii, but it's 2 times the 1 radius, or length of 2 radii. Yep.
It could be diagonal, right? It just needed to cut it in half, right?
Yeah, as long as it goes through the center there, and it has the endpoints on the circle, it fits our definition of a diameter.
Diameter is a hot knife challenge.
Is it named after that Greek god?
Oh,
The meter?
the meter?
The meter.
No, it's a diameter.
Diameter.
Laser kid for
Seth is asking all sorts of questions. I just do not know the answer today.
They're probably 27.
All right. Secant. Secant is a line.
Can.
Secant? Okay. Secant is a line that intersects the circle in 2 places. So it's a line that intersects or cuts through the circle in 2 different places. Now, one way that might be an easy way to think about it is that it's a line that contains a chord. I'm going to write in there in parentheses, hey, this contains a chord.
Chord.
So like if we were to have some sort of chord here, x, y, but it continues in a line, we say that's the secant. So the secant is line xy or yx. The chord is segment xy or yx. So the difference between the segment, that's the chord, versus the secant, that is a line that contains one of those chords. Kelly.
Before I had you as a teacher, I used to think that all teachers had to have good handwriting. What gives me hope?
Yeah, that's fair. That's fair.
Like he has it because he's not.
It was both a destruction and like somewhat of a compliment at the same time, and I'll take that perfect blend
How was that a compliment?
because I gave her inspiration.
Oh.
Yeah. Yeah, trust me, you can be.
That's a bad hand.
Maybe he does teach us up, because he's not.
The more you get a handwriting, the smarter you are.
Maps.
Okay.
Now you're a clone.
Tangent.
I'm an alien.
The real Mr. Costello was
Tangent.
Yeah, what'd you do with them?
Hey, we saw tangent before with trig ratios, right?
Yeah.
Bill
Okay.
saw,
Yeah.
Tangent.
That's right.
Son.
Is a line that.
Jason, opposite over Jason.
Mhm.
It is.
I swear if that is what it is.
I
Ooh.
think it is because it's extra control or whatever that
A line that intersects the
Yeah,
circle
it's your song.
What line?
Old line.
at exactly 1 point. A line that intersects a circle at exactly 1 point.
Isn't that just basically skimming the circle?
Kinda.
Oh, I don't like
I guess in slang, yeah. Have you guys ever heard the word like going on a tangent as far as like conversation?
Yeah.
Okay. What's it mean if someone goes on a tangent?
Something different.
Off the road.
Okay, something different. What is it? Is it usually somewhat related to the topic?
No.
No.
Kinda.
Yeah.
Kinda. It like kind of relates, but then goes off somewhere else, doesn't it?
It relates
Okay.
for like 2 seconds.
That's actually the same idea of what happens here.
It's like fun.
So what happens here? That's kind of like Fun Talk Friday.
Exactly like fun.
Is
Touches it.
Oh, you play.
it just touches it barely? So they do have a level of intersection, but it's pretty minimal.
Or it's like how everything relates to shrimp.
Exactly. Okay. So
Shrimp is like onion. Onion.
so this is the other conversation that just kind of barely intersects the main conversation you're having. So you're going on a tangent. Okay. So it's a line that intersects at exactly 1 point. Okay. Saren.
Are you gonna ask this to prove how a triangle is a triangle?
No. Triangle's a triangle by definition. Yes.
Does that have anything to like do with actual tangent?
Yeah, there are relations between that and the tangent we learned for right triangle trigonometry. But that comes in more in like trigonometry, the actual class.
What about secant? How does that connect?
Yep, so secant is the not inverse, the reciprocal of cosine. Yep. Yep.
So the times.
Yep.
Wait, so how are we gonna graph that?
Don't even.
Okay, point of tangency. So we have a tangent, so we have the point of tangency. The point of tangency is, surprise, the point at which, blessing must rain down after, let's forget, at which the tangent line,
It didn't looks like the noun.
It's like 16.
Can we still like sort it?
No, he did not.
sure, no, yeah, I guess.
Sign.
The point at which the tangent line intersects the circle. Nope. So it's where the tangent line intersects the circle. So for our last example, what would be the point of tangency?
Q.
Q.
I have a kind of question.
Kind of. It's not a good question.
It kind of relates to this.
Yeah, trick question.
I'm
Okay.
not sure if it would be an actual thing. So what if you have like a line segment that goes into the circle but stops there, but then it goes out of the circle?
So it's like half a secant?
Yes.
Yeah, then it's not a secant.
But it's like it doesn't contain.
So inside of this ray, because it'd be a ray then if it has an endpoint and one line,
Yeah.
and one arrow, I should say, it would be a ray. So inside of that ray, there would be a chord.
That's weird.
Okay. Continuing on.
And Q is
I
the
don't like
whatever.
Q would have been the point of tangency there. Yep.
Why is there a minor arc, major arc, and arc?
Yes. So, central angles. Now we're going to talk about different angles and arcs now. Central angle gives you the idea it's going to be located where? Probably somewhere with the center, okay? So it's an angle with a vertex at the center. What? No way. And two sides that are radii. So the vertex is the center of the circle, and then the sides of the angle are radii.
Oh, there's 2 arcs for the arc.
So if we have our center of the circle, we have this radius PA, this radius PB. The central angle would be angle APB, for example, or BPA.
Dang me, what?
I almost asked how a circle could have angles, and we just randomly used a circle in my other class, so that's my one.
What a beautiful high moment for you. I don't know. Inscribed angles. So inscribed angle is an angle with a vertex on the circle and two sides that are chords. It kind of ends up being like a central angle that got like moved back, is kind of what it seems like. So C is a point on the line. Or excuse me, on the circle. I said on the line. C is a point on the circle. So that's the vertex, is a point on the circle. Then the sides are going to be two chords. CA is a chord, CB is a chord. So the angle ACB or BCA is an inscribed angle.
What does that last word say?
Chords, yep. All right, an arc. Arc is a, didn't draw there. A portion of the edge of the circle defined by two endpoints. So a portion of the edge of the circle defined by two endpoints. And we have a symbol for arc. It's a mini arc.
So a curved line is an arc.
Yes. Arc is the portion of the edge of the circle defined by two endpoints. We have the symbol there, which we said it kind of looks like a messed up frowny face. So let's say we had A on the circle, B on the circle. The arc would be this little portion connecting those two. So it's along the circle.
Right? Is it actually supposed to be like that?
Well, no, how it's supposed to be, and I'll do it in a different color so you can see how it's actually supposed to be. Okay, Jacob.
Get out.
It's just like that. You basically just draw over it, but that's really hard to see right now. So it's okay just to do that. Basically just making it bolder, okay? I'm just making it bolder is all. That's fine. Sure.
I just made it thick
Let's
for you.
go.
How do you know it's not the other way around?
We'll talk about that.
Why?
What the other way?
Because you asked the question and it's a good question.
Go, baby.
Okay. Anyone still need this or have questions on this? Cool.
Yeah, but why is it so easy?
Now we have a minor arc, a major arc, and a semicircle. So these are all different categories of arcs, subsections of arcs. So a minor arc is going to be an arc that's under 18 years old. Just kidding. It's going to be an arc
Hot.
with a measure less than 180 degrees. What's the full measure around a circle? 360. So less than 180, it's less than half. Okay? A little note here. We're going to use two letters. We're going to use two letters to name the minor arc. Two letters to name it. So here, let's say we have points A, B, and C on the circle. And we're talking about the arc between A and B. So we'd say arc AB. Just like that.
Wait, what were the letters for just the regular arc, right?
I just did A and B. I mean, realistically, it doesn't matter. But
Why is this C there?
you'll notice that in a moment of why it's there.
No, I really noticed it.
Yes, you'll notice in a moment why it's there.
That looks the exact same as.
So, the major arc is an arc with a measure. Any guesses? Any guesses?
More than 180.
Yeah, more than, greater than.
That's older than 18.
Yes. Greater than 180 degrees. Little note here. We're going to use three letters to name it.
Why not?
Differentiation.
How do you just name an arc then?
Minor.
Or do you name it?
Arc AB.
Someone's out there naming it.
But that's a minor arc.
Oh,
It's an organ,
yeah.
that's why.
So this would be the major arc. So we'll connect it this way. A, B, and C. Notice I'm putting these in about the same place, right? As before. So we're talking about the major arc, A, C, B. It's going to go from A to C to B. So that's how we know whether or not it's going A to B the short way or the long way. Of whether or not we use 3 letters to indicate it's a major arc, more than 180. And we're specifying, hey, it goes from A to C to B. So we specify where the path it goes along. Whereas here, A to B, we know it's going to be the minor arc because it's 2 points instead of 3. Okay, so that's how we know. And that's why I put the C there on the one previously, so that way we can see the contrast right there. Questions on those two? Okay. Then for now, our last definition before we get to some formulas is a semicircle. It's literally right below it on your packet.
Can I guess?
So it's an arc.
With a measure of 180.
Yep.
Yes.
With endpoints on the diameter, meaning the measure is going to be 180. So it's always 180 degrees. It's half the circle. So here, if we have the center P, we need to know where the center is, so that way we know this is a diameter. Because if you don't know it's a diameter, you don't know it's going to be a semicircle. Now, for a semicircle, you will also use 3 points. For a semicircle, you'll also use 3 points. So anything other than a minor arc, you use 3 points. Minor arc, you use 2. But as soon as you get bigger, 180 or bigger, you'll use 3. Because otherwise, if we didn't use 3 here, we wouldn't know which direction along the circle it goes. Whether in this case it's the top portion or the bottom portion. So we have to use that third letter, K, in order to differentiate that. Does that make sense? Cool beans.
Wait,
What's up?
so if you put it like JLK, then it wouldn't be a semicircle, right?
Correct. Yep. JLK would be a major arc. It would incorporate everything except for the shortest distance between J to K at the minor arc. Okay, continuing on then. Some formulas. Area. Area A is equal to pi r squared, where r is the radius.
Sarah.
Yeah, please stop, Sarah. Okay, so area is equal to pi times r being squared. Just the r, the radius there, is being squared, multiplied by pi. Calculators oftentimes will have a pi button that you can use. Otherwise, you can type in 3.14 for a decent approximate. Circumference C, capital C, is equal to 2 times pi times r. Or you could say circumference is equal to pi times d. What would d stand for?
Diameter.
Diameter.
How many things of pi do you
3.14159, and that's like it.
926,585.
Sure.
I used to
So
go farther, but
does it make sense why these two would be equivalent to each other? Because what is 2 times the radius? The diameter. And the diameter is twice the radius. So they're interchangeable depending. Now personally, I find the top one to just be more practical for me. But if you want to try to use the bottom one, that's perfectly fine. They're really the same thing at the end of the day. Bill.
Wouldn't it be 2 pi times diameter?
No. Because so when you multiply, it can be multiplied in any order. So we're saying if we take 2 times r, it's the same thing as diameter.
Okay.
Because diameter is twice the radius. Diameter is twice the radius.
I don't know. Yeah, sure.
Okay.
Wait, so what?
I know diameter is twice the radius.
Okay, so diameter is twice the
Yeah,
radius.
but wouldn't you also have to map like pi?
No, because it's not a parenthesis. It's not like being added in. Because when you multiply, just like if you multiply, let's say the numbers 2 times 3 times 4. Well, if I do 2 times 3, I get 6. Times 4, that's 24. Well, if I also start with the same thing and I do 2 times 4 to start, 3 times 8, I still get the same 24. Now, if we were doing addition, like 2 times 3 plus 4, then we would need to distribute. But that's not what's happening here. It's just all multiplication. So we say we don't actually care about the order we're multiplying in. Does that make more sense?
Doesn't matter what order you multiply in. That's
I'm
it.
thinking you would have to, like, for the 2, you would have to do to both of them. That's confusing.
No, you don't.
Okay. That's
Because it's not addition.
Okay.
Arc length. We're going to cover this one not really much today, but we're going to write it down. I'm going to call it AL. Does anyone know what AL is going to stand for? Arc length. Man, you guys are smart.
Wow.
Is that L have a little curvy thing on the top?
Yeah, I put it there just that way I differentiate it from 1. Because I find oftentimes if I don't put a little tail at the bottom, it gets mistaken as a
Why
1.
not just
I
cursive?
accidentally did that.
Yeah, if you want to use cursive, you can. AL is going to equal to AM times C, capital C, excuse me, over 360. AM is going to equal our arc measure. And then C is the circumference, just like we saw before. So AM is going to equal the arc measure times the circumference divided by 360. And we'll talk about later when we go into this why that works. What's up?
Wouldn't that just be like a chord of it? Like the arc measure was that a chord?
No, we'll talk about how to measure arcs later. That's not something we're going to get into today. I'm just giving you the formula today. Yes.
Let's say AM times C.
Yes. AM's one thing. Arc measure times the C. Which I know it's weird to see 2 letters from math and be like, that's one thing. All right.
Oh no.
Name that circle part.
No.
So, no blurting. Raise your hand. Segment LQ. L to Q. What type of part of the circle is this? Kaya. It's a tangent. It intersects at exactly one line. Or 1 point, excuse me. It should be a line out of segment, you're correct.
That's why I was like, oh, wait.
Yeah, it should be a line out of segment. A lot of these should be lines, not segments. Nope, we'll reuse some. It's one of those bad ones. Okay? Number 2, segment WY. WY. Saren? Oh, you had your hand up.
Oh, there you go. That's chord.
Yep, it is a chord.
It's wrong. It's actually a chord.
Okay? 3, angle NQR. NQR.
Dude, what's this central?
I know what this one is.
Seth?
Inscribed angle.
Yes, it's an inscribed angle. The angle where the vertex is on the circle and the sides are chords. Point X. Liam?
Center.
Yep, that's the center.
No, maybe.
The major arc, as I say it, RWU.
You try to find that.
Dominic. Major arc. The line ST. Yep,
That's tangent.
that's a tangent. That's a more true tangent being a line. The segment PN. PN. Aiden. Yep, it's a radius. Goes from the center to a point on the circle. 8, angle UXY. Kelly?
Inscribed angle.
Not quite. Max? Central angle. An angle with the vertex at the center, hence the name, central angle, and the sides of radii. 9, the arc MQ. Saren?
Minor arc.
It's a minor arc. It's less than 180. Less than half the circle.
And it's only 2.
And it's only 2. The segment QN. Jacob?
Diameter.
Yep, it's a diameter. It's a chord that passes through the center. Now, would it be wrong necessarily to call it a chord? No, because it is, but it's more specific to call it diameter, right? You guys are probably pretty used to that in school by now, saying it the most specific name for it. Okay, continuing on to the next ones. 11, point R. Gauge?
Point of Tangency.
Very good. Point of tangency. It's where the tangent line intersects the circle.
Can we just call that? Alright.
No. 12, the line UY. The line UY. Aiden. Not quite. Nope. Secant. It's a line that contains the chord. So a chord would be a segment. On 12, line UY. Arc QRN. Arc QRN. Kaya. Yep, it's a semicircle. It's an arc that goes, the endpoints being diameter. 14, angle MPQ. Angle MPQ. Dominic? Central angle. Vertex is at the center. Sides are radii. 15, segment QR. Aiden? Yep, it's a chord. I know. 16, angle UYR. Max? Inscribed angle. I'm going to call some different people for these. 17, arc WY. Arc WY. Anna. Yep, it's a minor arc, less than 180. And it's only 2 letters. 18, segment L to N. Segment L to N. And we're going to actually pretend for this one that it's a line L to N. We're going to pretend for this one it's a line L to N. I'll go ahead and say that. Okay? Seth. Secant. $19, segment UX. Sierra.
Radius.
Yeah. And 20, the arc RUY. RUY. Let's go with Israel. Very good, semicircle. Question on any of those, guys?
Question.
Yes.
Why is secant orange?
Because I had to add in the fact that it's lines. So I just made it different for that.
Did you start the binding?
Orange, you glad I didn't say
No.
banana?
No. What came first, the color or the fruit?
I don't know. I would imagine the fruit was named first, but I don't know, that's my personal thought.
Are we gonna work through this?
I mean, they didn't have the same name.
I have a question.
Close. Just about.
Are we gonna have homework?
I'm a jerk. Yes.
Why does this seem easy?
Because you're bad.
It's just vocab.
Okay.
All right, area and circumference. We talked about the area formula was A is equal to pi r squared. Circumference formula is C is equal to 2 pi r, or C is equal to pi times diameter. Now, one of the reasons I like the 2 pi r more than pi times diameter personally is because area already uses radius, right? So I find radius just be more helpful because I can use it for both formulas, whereas diameter, I have to alter it to use it for the area there. But really, it comes down to your preference again. I have my preference, which is why I say that. All right, on 1 through 4, find the area. On 5 through 8, we'll find the circumference. So if 1, what's this? That's 12 meters.
The radius.
The radius. So the radius is 12. So we plug this in to find the area. A is equal to pi r squared. So A is equal to pi times 12 being squared. What's 12 squared?
144.
144. So it's 144 pi. And we can approximate that by typing it into our calculator. 144 times pi, or 144 times 3.14. And we get approximately 452.39. And does anyone know what our unit would be here for area? Okay, square meters. We write it as if it's meters squared, but we say it as if it's square meters. So we write it meters squared, but it's actually pronounced or said square meters.
You always want to go to the 100.
Sure. That's a good rule of thumb. Questions on number 1. What's going to be the curveball here on number 2?
It already has a diameter.
The diameter.
You're given the diameter.
Why not 2?
So what's the radius? 9 inches. So then as you put this in, you have pi 9 squared, which is 81 pi, right? And what's that approximately, Max? Oh, sorry. What were we going to ask then?
So, like on homework, if we're not using like a calculator or something, we just use a 3.14.
Yep.
And it won't, so obviously you won't get like the same thing if you.
Yeah, if you show that you multiply by 3.14, I can track with that.
Okay.
Yep. Great question. What does it end up being? 81 pi. Jacob?
254.34 square meters.
Did you do 3.14 or the pi button?
3.14.
Okay. So that would give it that 254 what?
3.4.
3.4. And that's square inches. Does anyone use the pi button? Kelly, what'd you get?
I got 254.46.
Okay, 4.6 or 4.7, I think, if you round up.
Yeah.
Okay. So either way, are those both pretty close? Yeah, so that's just the slight difference between using 3.14 and then the full pi, which is 3.14159, blah, 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 and it keeps going. Questions on that? Do you guys feel comfortable doing 3 and 4?
Sure.
Is that just algebra?
Yeah.
Yeah, it's just algebra. Okay, let's move on. 5 through 8, we're doing circumference. So we're using just a different formula. Circumference is equal to 2 pi r or pi times d. So on 5, circumference is equal to 2 times pi times 7. Well, 2 times pi is 14, so 14 pi, which is approximately
43.98.
okay, 43.98. Then what's the unit here? Millimeters. And it's not square millimeters. It's just millimeters. Saren.
I got 43.96.
Okay, did you use 3.14?
Yes.
That would do it. It's just a slight difference in the two, and that's okay. 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 Now, if your calculator does have a pi button, please use the pi button. If your calculator does have a pi button, use it. It's more precise.
Mine doesn't.
Really?
Oh, wait, never mind.
There it is. I was going to say, there's no way it doesn't. All right. On 7, do we have to use the radius? No, what could you use? Diameter. You could say, here, the circumference is equal to 58 just times pi. Now, if you wanted to go back a step and say, circumference is equal to 2 times pi times 29, half of 58, you could, right? You'd get here anyway. And what's that end up being approximately on number 7?
182.21.
Yeah, 182.21 yards. Notice I'm putting the approximate symbol on all these, right? Because it's not exact anymore when we use an irrational number like pi. Question on that?
This seems surprising.
Good. All right. We're going to do just a couple more problems and then be done.
This is an English class.
Let's say we're going the other direction. We're just going to use the formula the other way. We've done problems like this before, actually, just with different parts or different formulas. So find the diameter with a circumference of 65.97. Well, if you know circumference is pi times diameter, or 2 times pi times r, this time we know the circumference. So we plug in that 65.97, and it's equal to pi times diameter. If I'm trying to get diameter by itself, how do I get that by itself? Divide each side by pi, because it's multiplying with pi. So take 65.97 and divide that by pi.
21.98.
Yeah.
21.
You just get 21, right?
Yeah, it's just 21. It's
Just
20.99.
21 meters. Or approximately 21 meters. Does that make sense? You took the same formula and you just repurposed it is all. Have we done stuff like that? Yeah, I think so.
Who would make a circle with a circumference of 21.99 feet? That's just me.
All right. Continuing on. Let's do one with the area. So let's do number 13. Find the diameter of a circle with an area of 615.75 centimeters, or square centimeters, excuse me. Area is equal to pi r squared. So 615.75 is equal to pi r squared. What's my first step in finding the radius?
Dividing by pi.
Dividing by pi. So r squared is approximately what?
196.
196. And what's my next step in getting r by itself?
Square root it.
Square root to undo the square. Square and a square root undo each other. And so we do it to both sides. So r is equal to, or approximately I should say, 14. And now we could say positive or negative 14, but can you have a negative radius?
No.
No, it's not possible because it's a measure.
Oh dear.
We could go to the fourth dimension to say that.
What was that?
13 and 14 always mess me up because they're like 169.
And 196. Yeah. 4 times 4 is 16, so it ends in a 6. 3 times 3 is 9, ends in a 9. Yes.
Hey, we're not looking for the radius. We're looking for the diameter.
Oh, we're looking for the diameter. Are we done?
We are not done.
No, what do we have to do, Gage?
We have to add. We have to times by 2.
No, times by 2, double it. So we get what? 28 centimeters. Thank you, Gage. Good catch.
Wait.
Imaginary bonus points.
That was Liam.
No, it's not square anymore. Okay, good catch, Liam. Imaginary bonus points.
He just-
Yes.
Do we multiply the decimal by 2 or just make it simple?
Either way, I'd be good with. Question on that? Okay. I'm going to leave the rest of the problems actually as more of a challenge to you as we go to the homework a little bit. All right, here in the bottom right-hand corner, I'll tell you which ones to do. I want you to do number 1, which is like A through I, so obviously that's a big one, okay? But it's also just the naming one, so hopefully it should go pretty quickly. I want you to do, let's go 1 through 3, 6. 6 through
6 through 17.
10. And
17.
13 and 14.